I decided to add another bonus chapter, and this is for people who need, say, a demo solar setup, or maybe you're going out in the field on a camping trip, or you're a ham radio operator and you need to do some field operations, but you need a small compact setup. Well, here's how to set a very small, straightforward solar-powered system together from start to finish.
Now let's take a look at all of the pieces you're going to need in your portable small solar power system. On the top left, of course, is your solar panel. And normally for small systems, we're talking in the range of 40 to 120 watts. Now, the output of that is going to go into the charge controller, and it's going to be wired up into the PV panel input on your charge controller, which is marked plus and minus. Your panel's outputs are also marked plus and minus. And as I've shown there, try to keep that lead short, say under 10 feet, and use 10 to 12 gauge stranded wire. Now, the charge controller also has a marking for battery, plus and minus. And you're going to run your wires from there to the battery, whether you're using a wet cell or a dry cell like this, the AGM enclosed non-leaking variety. And I'm saying under 10 feet, run on that if at all possible as well. The shorter, the better. And 10 to 12 gauge wire, stranded wire, is also ideal for that. Then, from your battery, going to your inverter, if you do need 110 volts, is going to be a very short run of 4 gauge wire or larger. Now, inverters have to have large wire coming from the batteries, so as short as possible and as thick as possible. I'm saying minimum 4 gauge and maximum 5 foot of a run. You may not need the 110 volts AC with the inverter at all, but if you do, use short and thick wire. Maybe you have 12 volt equipment, you won't need the inverter at all. All of this equipment usually can go in one place because on a portable setup, it can sort of be co-located. And with nice short wiring and a nice stout setup with the equipment, you're going to have very, very good performance. Now, before we go out and buy any hardware, we're going to need to determine what to buy. So here's how you do that. So the first question is, what are we going to power? First, you need to find the watts that each item you want to power draws, and that's usually on a small little plate on the back of it or in the instruction manual. And then you've got to figure, how many hours a day am I going to have this thing turned on? So that's the second number. When you multiply the hours of use times the total watts of everything that you're going to use, that's your watt hours needed daily. So to determine your panel size, take your total watt hours and divide by 5. That's going to be your panel size. Of course, slightly larger is even better, so look out there, find a good deal, and round that number up to the next larger size panel if possible. The next piece of gear is the charge controller. And for a 12 volt system, which is absolutely the most typical for portable or demo operation, you want to divide the panel's watt size by 12. Now this equals the amount of amps that the panel provides. In reality, it's going to deliver a little bit more because your charging voltage is a little bit higher. So your charge controller needs to be about 25% larger than this number minimum. And the controller will be rated in the volts, in this case a 12 volt system, and the amps maximum that it can handle. So you should get one that can handle at least 25% more than the panel puts out. Up to a little bit more than that's just fine depending on your budget. They tend to come in even number of amps, so just round it up to a nice even number above that. And lastly, we're going to determine our battery size. Now first, remember you're going to match the panel voltage, the charge controller voltage, and the battery voltage. All these need to be, say, 12 volts if you're running a 12 volt system for portable. So you take your amps out of the panel, that number that we got before, and multiply it by 10 to 20. This resulting number is the total amp hours that the battery needs to be, or higher. You must use a deep cycle or AGM battery. Remember that, because the others are not even rated in amp hours. Now, 10 times the amps will give you 1 day of extra power. That means if you had a day of sunlight and then you had a day of cloudiness, partial cloudiness, you'd probably have enough power to get through that. More like 2 days of sun, 1 day of clouds. And if you go to 20, that's going to give you more like 3 days of extra power. So depending on how long you're going to be out there using the system, what kind of cloud cover you're expecting, and what size battery you want to carry. For a small portable operation, really 10 times is usually enough. So let's take a look at some typical system components.
Well, here's a Sunsaver 6.
It's currently offered great little charge controller for portable operation. It would be ideal. Connections are very simple. It's a 12-volt charge controller. Solar panel goes here, plus and minus connections. You can use bare wire right under these little screw heads. Battery plus and minus right here. Plus, minus, screw them right down. Be sure there's no shorting wires. That's what these little blockades are for here. It also has a load output, so if you wanted to actually connect it to a load, that means something that you're running, you could run it right off of here, a 12-volt load, but you can also connect your inverter or your 12-volt items that you're using right to the battery connection through a fuse. This also has a little jumper wire over here, and as it says, remove jumper wire for a flooded battery. So, as it is right now where there's no jumper, if you're using a wet cell, that's ready to go. If you wanted to use the AGM sealed, you'd have to jump a little jumper wire over to let this controller know that you are running a sealed battery. And here's an amorphous panel here that literally rolls out and rolls back up. You can put it in a bag and take it with you camping. And I have it connected on the end with the Anderson power pole, as I've showed before, usable for small power connections between your charge controller and the batteries and such. These are available on eBay, as well as the panels. These two lines have a couple of fuse holders in them, and these are just terrific panels for portable use. Here's a small 40-watt panel, rigid panel, not the flexible kind. I like to use these for portable operation, and I'll show you how I hook them up. So here's the connection box on my little 40-watt panel. It's got screw heads for lugs or wires, so I've got my two little wires going onto the plus and minus, which are clearly marked. I added a little bit of red tape to my red side connection there to really make it obvious, and then it goes out of two little rubber grommets on the bottom over here, and I added a couple of twist ties on them to be sure that you couldn't pull them out like that if you gave a tug on the wire. So connection is really quite straightforward. The top of this box just slid off, yours may screw off, but most of the smaller panels have a bare wire type of connection, or you can use these little lugs and put them on the end of your wires so you can solder them on there. Here's another charge controller you've seen earlier in the video, perfect for portable or demo operation or permanent small system installation. And its connections on the back are always going to be pretty much the same type of stuff that I've been showing you. You've got a battery connection, plus and minus, and you've got an array connection, plus and minus. But see, the way this one's laid out, both negative connections are on the bottom two, and both positives are on the top two. So when you're doing your battery, you'd go this bugger right here, and the very top one for plus, negative on the bottom. And the array is going to go in the center, negative and positive. Notice I added a little bit of red tape on my connection here to really make sure I didn't mix them up. Then I put a little twist ties on here to strain relieve it. This unit has built-in fuses. Most of them do, which are replaceable. So there you go, pretty easy connection on the back of this. Something I did add as a little bonus extra on here was I added a couple more wires connecting to the array plus and minus, and I brought them out to a couple little connectors, little banana connectors over here. You could use any kind of connector. What this allows me to do is add another solar panel in parallel with this one. So you could just put the plus and minus from another panel right into this one, and you could double your power. So what I did with this charge controller is I mounted it directly to the back of the panel over here. I just drilled a couple of small holes and used self-tapping screws and mounted it right into the corner next to the panel's own junction box. And there we go. The little pigtails are hanging out to connect another panel to if I want to, or I can just run it autonomously. And as you can see, it's already getting juice from the panel, even though we're not in the sun, showing some 13.8 volts. So this makes this a sort of self-contained unit. Now remember, when you take these rigid panels out, you still have to be very careful of not banging the back. This rubber-coated material, silicone cover over here, is very delicate, so no sharp objects hitting the back of this. So I'll screw my little charge controller right back onto the back of this panel. So there it is, the charge controller screwed right onto the back of the panel corner and connected right up to the output box on the panel over there. Now, the battery connectors are coming off of here with some zip cord, very short, 2 or 3 feet. And what I did was just to put some alligator clips right on the end. And this makes it really easy to have a temporary hookup if you're out camping or whatever. And just alligator clip these right onto the top of the battery terminals. Red and black will keep you from getting into trouble. So for my camping trip, I've chosen a 26 amp hour AGM gel cell because I had a couple of these little babies and they're really nice. You know, you can't spill anything out of them and they're really heavy duty. Now, for service output, what I did was I got a little cigarette lighter female connector here from Radio Shack,
and I soldered it right onto the tabs of the batteries up here for my output. And this has a built-in fuse in it, and it's ready to go. And I'll show you why I do that. But first, let me tell you that the output from the solar panel in the background, I just take my alligator clips and clip it right onto the lugs over here. Remember to keep these wires as short as possible. Sometimes you can put your battery right in back of the panel. And I am ready to go. Now on the output, I'm using a little 100-watt plug-in inverter over here because I need to run a laptop and some other stuff and some lighting that I wanted 110 for, as well as my 12-volt stuff. So I just take this little cigarette lighter plug and I can plug my inverter right into it, and it's ready to go. It's on. Plus it even has a USB charge port on it, so it's really handy. As well, a good idea on these is to take some electrical tape, 2 or 3 runs of it, and cover the terminals when you're using the battery or whenever, because you don't want to drop something or short these babies out over here. And here's a really interesting thing you might consider. I took a couple of AGM gel cells, security type batteries you can pick up at the battery store, and put them in a toolbox, sort of a plastic toolbox, and I added a few little things here. I've just wired the batteries, plus and minus, to a couple of connectors over here. These are called Anderson power pole connectors, a very common type for 12-volt systems. I've got 2 of them on here because I use one for the output and one for the input. And you can connect your charge controller right to one of these connectors over here. And I also added a little voltmeter display. These are available on eBay and other places. Basically, it's just a simple voltmeter, and I just wired that directly to the batteries, but I did put a switch in line with a little push button over here such that I can push the button and it'll connect the meter up to the batteries and give me the display voltage of how the battery condition is. Pretty keen, inexpensive, and very good for camping. Pick it up with one handle and take it with you. So say you're using a wet cell in your portable system. Here's one I'm using on a small system. My power leads are coming in right to the battery, screwed down on these nice terminals that are provided on these kind of trolling batteries. There happens to be a fuse in line with the wire coming in. I just happen to be, and that's always good. More fuses are better. But I used one of these nice battery enclosure boxes, and I screwed the charge controller right to the top of the battery box. So it's mounted securely right on top, and you can do that quite easily. So the only thing you have coming out is your wires going to the solar panel, which you can connect up easily. You can even put connectors on, like I showed you, those little banana connectors for the output of the panel, and your service output wire, black and red. So it's nice and self-contained, and the box is good if you're using wet cell. Keep that battery acid from getting on anything. Now when you're wiring up your system, you're going to need to take the insulation off of some of the wires. So you can use a pocket knife for this, especially out in the field, and just put the wire, about a 1/4 inch or 1/2 inch from the end, whatever you need stripped, as we call it, and push gently with your thumb until you feel the blade go into the center and hit that metal. Don't push too hard or you will take the metal off. Then just pull off like this and you get the nice bare end. Now, you can just use these bare ends and put them right under the connections on most of this stuff. Now, this is solid core wire. For most of this, you're going to want stranded wire because it'll make a better connection. It's easier to work with, it's flexible, and that's why it costs a little bit more. But go with stranded if you can. And you can use the bare ends, or you can go deluxe and get a lug. Here's what a lug looks like. These little things that go right under the little screw heads. Make it all tidy. And so, if you look at the section on soldering in this tutorial, this video, you'll see how to put these on. But basically, they just slip over the wire at the end, goes in there, and then you take your soldering gun and heat it up right there, right at the connection point, and flow your solder into there, and be sure that it has a few seconds to harden. And then you'll have a nice sort of professional-looking wiring setup. And then use some of those little twist ties or pull ties to sort of tidy up your wire work at the end and keep them from being pulled on.
Lastly, I'd like to talk about the tools you might want to take along with you if you're out camping or going to be out portable for a while, even if you're giving a demo for a while, because you want to be sure that your system works and stays working. So, of course, a small voltmeter would be a good idea. You can check the battery voltage, different things going on, some electrical tape, screwdrivers, wrench, little hand tools, a little bottle of distilled H2O, some water. If you're going to be out for quite a few days, you just want to be sure your battery's topped off. A portable soldering iron is not a bad idea. They make them in butane. They're very nice, but keep that butane soldering gun away from the battery where those explosive gases are. a little bit of extra wire of both types that you're going to be using, some lugs, some solder, and extra fuses of the amp rating that you have in the back of your charge controller or in the lines with your battery and panel. So if you have this stuff, you probably won't need it. But if you don't take it, you might need it. So there you go. Everything you need to know to set up a small, efficient, and reliable solar power system.